Time-saving tip: if you're using ampicillin as your selectable marker for seeing if bacteria took in a plasmid of interest and then only allowing them to grow if they did, you can go ahead and save yourself some time and skip the outgrowth step. And you can skip the outgrowth step with ampicillin because the ampicillin targets the bacterial wall synthesis, not the protein synthesis. With other antibiotics, things like kanamycin, tetracycline, chloramphenicol, all of these are going to need that outgrowth step where you allow them to recover from the transformation in the absence of the antibiotics. Give them time to make the proteins that will inhibit the antibiotic before the antibiotic prevents them from making proteins. So when we do a bacterial transformation, we stick a plasmid into bacteria, and that plasmid has the gene of interest for us. So maybe the instructions for making a protein you want the bacteria to make, and it also has an antibiotic resistance gene. And then the bacteria that take in the plasmid will be able to make a protein that is then going to allow them to survive in the presence of the antibiotic. But the bacteria that don't take in a plasmid aren't going to be able to grow. And so this way you're able to select or only allow to grow the bacteria that actually have your plasmid. And typically after you do that transformation, you then do an outgrowth where you add like a nutrient media. So you can either do like a super rich media like SOC, or just I normally do typical LB. And then you allow them to grow in the absence of antibiotic in just like a little shaker in a tube. And then you go ahead and plate it on your plate. And the reason why you do this is to allow the bacteria time to recover and to make the proteins that they need in order to combat the antibiotic. And so outgrowth is really important for if you're using things like kanamycin for your selection, or tetracycline, or chloramphenicol. All of those antibiotics target the bacterial ribosome. And the bacterial ribosome is what the bacteria needs in order to make protein. In order to make proteins like the protein that it uses in order to do things like modify the antibiotic so it's not harmful anymore, ship out the antibiotic, or modify their ribosome so that it doesn't bind to the antibiotic. So different resistance mechanisms work by different strategies, but all of them are going to involve making proteins. But only some of the antibiotics are actually going to target the protein maker, the bacterial ribosome. Ampicillin works differently. Ampicillin targets the bacterial cell wall maker, and so it's going to target the enzyme that actually puts together and strengthens the cell wall. And the bacteria need that cell wall maker in order to survive long term and to grow and make copies of themselves and all that. But it's not like bactericidal. It's not going to kill them right away. Instead, it just kind of prevents them from growing. But during that time, the bacteria has time to be making the proteins that then it can use to combat the antibiotic. And so it has plenty of time before it dies, even if you are inhibiting its cell wall making, for it to go and make those proteins. And because you're not targeting the ribosome, it can go and make those proteins. And so it's going to make a protein that is then going to get shipped out of the cell, and it's actually going to degrade the antibiotic in the environment. And so what happens though is that it can also kind of then provide resistance to the cells around it. And so a bad thing about ampicillin is that you can kind of get satellite colonies, and so you get like big colonies and then little colonies next to it. And those little colonies next to it might be bacteria that actually lost the plasmid, but they're able to still survive because they're in the presence of that antibiotic resistance thing, that enzyme that's out there. And so this beta-lactamase is actually typically goes and then it breaks down the antibiotic so it can't hurt the bacteria. So that's a bad thing about ampicillin, is that it can kind of get these satellite colonies where it's sharing resistance with bacteria that don't actually have the plasmid, and so that's why you want to make sure you don't overgrow it. But the good thing about ampicillin is that you can skip that outgrowth step